Dalton'S law of partial pressure. If I have gas A in a container, the pressure in the container is exerted by the gas A, and I will write it as PA. If I have gas B in the same container, the pressure in the container is exerted by the gas B, and I will write it as PB. When I mix both gas A and gas B in the same container, now it becomes the mixture of gas A and gas B. The pressure in the container now has become the P total of partial pressure A and partial pressure B. This is what is stated by the Dalton's law. In a mixture of unreacting gases, the total pressure is the sum of the partial pressure exerted by each gas in the mixture at constant volume and temperature. If we write it as an equation, we will write it as P total equal to PA plus PB plus PC, and so on. Now we will discuss about the combination of Dalton's law of partial pressure and ideal gas law in the water displacement method. To make our discussion easier, I will use this problem solving to show the combination of Dalton's law of partial pressure and ideal gas equation. Let's read the question first. By using water displacement method, 128 ml of oxygen gas was collected from the decomposition of potassium chlorate at 24 degrees Celsius and atmospheric pressure of 762 mm mercury. Calculate the mass of the oxygen gas obtained. The vapor pressure of water at 24 degrees Celsius was 24 mm mercury. This is the illustration of water displacement method. We have conical flask, which the reaction producing gas inside the conical flask. We have delivery tube, we have water, and also the test tube inside the water. From the question that we have read before, this is the reaction of decomposition of potassium chlorate, which produce potassium chloride and oxygen gas. The oxygen gas produced will go through this delivery tube, will go through the water, and will be collected over water. In this column, there is not only oxygen gas is collected, but there is also water vapor inside the column. And now, the P inside here is exerted by the P total, which is equal to PH2O and P oxygen. We also have P outside, which is the atmospheric pressure, and until it reaches the equilibrium, the P outside will equal to P inside. We know that P outside is equal to atmospheric pressure equal to P total, which is P oxygen plus PH2O. By substituting the value that we know from the question, we already have the atmospheric pressure, which is 762 mm mercury, equal to P oxygen plus water vapor, which is 24 mm mercury. Rearrange the equation to have the P oxygen equal to 738 mm mercury. Now, the question asks about the mass of oxygen gas. That's why we have to apply the ideal gas equation, which is PV equal to nRT. We have to derive this equation so that we will have the term, we have the mass variable here, N equal to mass over molar mass. Rearrange the equation so that mass will be the title of the equation. And now we substitute all values that we already have from the question. First, we already have the pressure of oxygen, which is 0.971 atm, volume of gas, which is 0.128 liter, molar mass of oxygen, which is 32 gram per mole, constant, gas constant, which is 0.08206 atm liter per mole per Kelvin, and we also have the temperature, which is 24 degrees Celsius, equal to 297.15 Kelvin. By substituting all the values that we have, we will find the value of mass of oxygen gas obtained from the water displacement method, which is